Hello. I've changed things, obviously. I'm in my dining room and I am going to be doing this with my Chromebook because it uploads a whole lot quicker than my regular computer does. So now we're looking at logarithmic functions. Exciting, right? So f of x equals a to the x. This is an exponential like what we looked at before, right? And if I want to find the inverse of this, like we did in 10.1, then we're going to look back and we're going to say, okay, if I want the inverse, I'm going to change my f of x into a y, right? That's our first step, is to change it into a y. Go ahead. Hold on a sec. Yep.
Hi!
There's my daughter with her crazy hair. Okay, bye. Bye.
I love you, bye!
Okay. She's excited. All right.
My mother misses you.
I do miss you. All right. So for this one, as soon as we get it to this point right here, there's kind of an uh-oh moment. Right? Remember? Oh, no, not a happy face, an unhappy face. Right? So as we're trying to find the inverse, we have to be able to get x by itself. And at this point, we don't have a way to get x out of that exponent. And that's where we've got logs to the rescue. Okay, logs to the rescue. So a logarithmic function is something that will take this and turn it into something that we can get that x all by itself. So if I have a to the y equals x, then what I know is y is equal to log base a of x. Okay, so I'm going to move this closer. Is there a glare? Hold on. There we go. Okay, so if I've got a to the y, remember that when we're dealing with an exponential function, this is called my base, right? My base becomes the base of my log function. My exponent becomes out here all by itself. And then the number that this thing to the exponent is equal to is going to be right there next to my log. So this might seem a little confusing. We're going to look at quite a few examples and practice with it so that we can get familiar with it. Sound good?
What are you doing?
Okay. Allie, no talking right now, please. Thank you. So if I've got, say I've got 3 squared equals 9, right? This is in exponential form or exponent form. And I want to change it into log form. The glare from my windows is really, really annoying. That's a little bit better. Okay. So I've got 3 squared equals 9. What I can do is I can take it, my exponent goes out by itself, and this becomes the base of my log, and then this goes next to it. So it's almost like we're making a big circle. So I'm going to have 2 is equal to log base 3 of 9. Okay? So once again, I start with my exponent. My exponent comes out by itself. The base becomes the base, and then the number that it's equal to comes out next to it. Let's look at another one. Let's look at 7 to the 1/2 equals the square root of 7. Looks like it's going to be a lot more complicated because I've got fractions and radicals, but it works the same way. I'm still going to take it and wrap it around. So I've got 1/2, my exponent's by itself, log, and then the base of my function becomes the base of my log function. And then this piece right here becomes that piece that's next to it. Okay, let me erase and look at another one. Where'd my eraser go? Here it is. Let's say I'm going to change it around now because you're going to see them both ways. So what if I've got that 25 is equal to 5 squared? So for this one, my exponent's up here, so I'm going to go from my exponent around to my other number, okay? So I'm still going to have 2 is equal to log. I figure out which one is my base because it's the base of my exponent becomes the base of my log function. And then 25 is the number of 5 squared, okay? Let's look at one with fractions. I know how much you guys love these things. equals 1 over 27. So I've got 1/3 to the x power equals 1 over 27. That stupid glare. There we go. Ha! It's gone. Okay. So I'm going to start with my exponent, right? Wrap it around. And then I've got log base 1/3, and then is equal to 1 over 27. Okay. Hopefully this is enough of an example of working from exponents to logs. Right, we're going from here to here, going from here to here. Now we're going to look at what if you're given a logarithmic equation, how can you turn it back into that exponential form? So what if you've got something like this? 3 equals log base 4 of 64. Okay, so what I'm going to do is I'm once again going to wrap around. I'm going to start at my base, go to my exponent, and then wrap around to my number. So I've got 4 cubed is equal to 64. Okay, I'm gonna give you this one. Let's say log x of 1 is equal to 0. Okay, we're always gonna start with our base, go to where the exponent is, right? Remember, this is my base, and this is my exponent. And then it's going to equal that number that's right there. So I'm going to wrap around like this. Even though my log's on the other side, I'm still going to start here. So I've got x to the 0 power is equal to 1. Okay. Let me look at another one here. I can probably get it written on here. -2 is equal to log base 10 of 1 over 100. That doesn't look like a 100. There we go. So I'm going to start at my base, go to where my exponent is, and then it's going to equal that number. So I've got 10 to the -2 is equal to 1 over 100. Okay, you're going to have several examples where you start off and all you're doing is changing form from one to the other. Whether it's given to you in log form or if it's given to you in exponent form, they want you to be able to switch back and forth. And the more you practice this, the more familiar you're going to become with these logs. Now, what if we need to evaluate these things? Because there are going to be times where you might need to figure out what x is equal to, right? There's going to be a variable in there and we need to solve for it. So let's look at log base x 36 equals 2. So let's look at this equation here. I've got log base x of 36 is equal to 2. There we go. The best way for us to be able to really understand what this says is to get it out of log form and put it back into exponential form, because then it's going to be something that we can solve. We're going to wrap this around like this, right? I've got my base, and then I've got my exponent is equal to 36. And I hope at this point that's something that we all can solve. X squared equals 36. In this case, because this is the base of an exponential function, my bases are always positive. So even though when we do quadratics and we take the square root, we usually do our plus or minus. In this case, we really only have one option, which is just x equals 6. Let's look at another one. Log base 5 of x is equal to 3. So I'm going to take it, wrap it around, right? This is my base, this is my exponent, that's the number it's equal to. 5 cubed is equal to x. Oh, well, we know what that is. So 5 cubed, or not 5 cubed anymore, sorry. X is equal to 125. Okay, let's look at one that might look a little bit harder because they're not even going to give you an equal sign. Let's say I've got log base 5 of 25. Okay, and if they give you something like this, they're going to say evaluate without using a calculator. And in this case, the easiest thing to do is to just turn it into an equation like what we just looked at. So what I'm going to do is I'm going to say that it equals x. Just plug that in there. I can now take it and wrap it around, and I'm going to have 5 to the x equals 25. And before, in the last one, we looked at being able to solve these exponential functions. And what we can do is rewrite this as a power of 5, right? So 5 to the x is equal to 5 squared, so I know that x is equal to 2. That one you probably could have done without rewriting, but not all of them are you going to be able to just figure it out. So sometimes that rewriting can really help. Okay, let's look at another one. Let's look at log base 1/2 of 1/4. Okay, once again, I can just plug in an x, right? I can unwrap it, so I've got 1/2 to the x power is equal to 1/4. Well, 1/4 I can write as a power of 1/2, right? I'm going to have 1/2 to the x power is equal to 1/2 squared again, so x is once again equal to 2. Okay, let's look at one more example, one that's a little bit more tricky. Let's look at log base 2 of 1/16. So the question that we're really asking whenever we see something like this is what power of 2 will give me 1/16 as my output? So if I just plug in that equals x, I can wrap it around again. So I've got 2 to the x is equal to 1/16. And we've got to remember, flipping things around gives us those negative exponents. I'm going to start with this piece right here and see if I can turn it into a power of 2. On this side, I've just got 2 to the x. This is 1/2 to the 4th, right? Because 16 is equal to 2 to the 4th. So then I've got 2 to the x is equal to 2 to the -4, right? In order to flip this back around, I've got to have it be a negative exponent, so that means that x is equal to -4. Okay? So far, all that we've looked at is just switching from exponential to logarithmic form. We're going to look at in another video how to graph these things because logarithmic functions are kind of fun to graph. Well, I think so. And we'll look and see what they look like that. And then next week, we'll look at properties of logs and how we can really solve equations with them and combine them and cool stuff like that. Okay? So remember, email me, message me, whatever it is that you need. If you need more help, let me know. And I've got that Google Classroom set up, so add things to it if you need to. All right, good luck.